Mr. Richens. Welcome to another lesson in physics. Today we're working on Unit 3, Kinematics. Lesson 2, Describing Motion. In order to describe motion, we're really interested in two things. Where are we? And when are we there? This is our position. And this is a question of time. Position and time are the two critical pieces of information needed to describe motion. Position, symbolized by x, or x of 0, if we're talking about our initial position, is our position relative to our reference point, our frame of reference, an origin that we've established. Time, symbolized as lowercase t or lowercase t sub 0 for our initial time, can be described in one of two ways. We have clock time, where we would record the actual time that we occupied the position, like 4:33 and 25 seconds p.m. That's a bit awkward for what we're going to be doing. So instead of clock time, we're going to be using elapsed time. For much of what we're going to be studying, we're not interested in what came before we start making our measurements or what comes after we stop making our measurements. And so we're going to record our initial time, generally, to be equal to 0 seconds. We'll start our recordings at time equals 0 and record each time interval until we're finished studying the motion that we're interested in. Because we're starting at 0 and recording intervals of time following 0, this is often called stopwatch time. Position will be measured in meters, since that's the standard for the measurement of dimension in the International System of Units. And we'll use seconds to record time, since that's the standard of unit of measurement for time. So let's look at an example of motion. We'll represent the motion by using a motion diagram. We draw a straight line, since we're dealing with one-dimensional motion, and we'll establish our reference point, 0 meters. And we'll imagine that that's where we begin. And we'll establish our time as 0 seconds. We'll mark off equal intervals on our scale and let each interval represent a meter. So that would be 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, 6 meters. And let's imagine that in each succeeding second, we travel 1 meter. So at 1 second, we've traveled to 1 meter. At 2 seconds, we've traveled to 2 meters. 3 seconds, we've traveled to 3 meters. 4 seconds, we've traveled to 4 meters. At 5 seconds, we've traveled to 5 meters. And after 6 seconds, we've reached 6 meters. And that's where we're going to stop our recordings. We have now a time and position for 7 different instances describing our motion. From this, we can determine other factors which we'll be covering in future lessons. But let's convert this motion diagram into another representation that is called a position versus time graph. And so we're going to draw a graph. We're going to put time on the horizontal axis. We're going to put position on the vertical axis. And we'll go 1, 2, 3, 4, 5, 6 for our time, and then 1, 2, 3, 4, 5, 6 for our distance. And so our positions on the position versus time graph would be plotted at 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So this would be the position which is 6 meters to the right of our origin and 6 seconds after our start. That would be our position, x, and this would be our time, t. These two types of representations are going to be very important in the course, and you'll be drawing quite a few of these. So this is what we call a motion diagram. And this is a position versus time graph. From this initial graph, we can derive another descriptor of motion. And that's what we'll do on our next lesson. So until then, have a good day.